that you can use when you are integrating. Then after that, the last thing in the chapter is on double and triple integrals. So double and triple integrals is just you integrate using all of these techniques that we have used. Okay, so these integrals these are integrals that are not reducible they're not reducible to one of the previous forms, but they contain the square root of a squared minus x squared, a squared plus x squared, or square root of x squared minus a squared. Okay, so you cannot rewrite them like we did the previous ones, but you can see that these square roots are there. Okay, so the way we solve them is pretty much the same in the sense that the substitutions we would make here are the same that we would make in the questions that we are solving over here. So we look at an example. So we have the integral of x squared over the square root of x squared plus 1. Okay, so previously what we would say is try and rewrite the numerator or split up the numerator so that one part is the derivative of the denominator and the other part you can use your arc, trig or arc hyperbolic functions, but here it is not possible because this is x to the power of 2. So you cannot split it up like that, but you can see here in the denominator, it contains the square root of x squared plus 1. So when we have the square root of x squared plus 1 in the numerator, we would make the substitution and say, let x equal to a tan theta. So here our a is 1, so this x is just equal to tan theta, and then we will substitute, there's a dx here, and then we will substitute the way that we always do. So if x is tan theta, then it means that dx is sec squared theta d theta, and now we substitute. This is the integral, so instead of x squared, we write tan squared theta, and then dx, this is sec squared theta d theta, and then in the denominator, x squared is tan squared theta, so we have tan squared theta plus 1 under the square root. And we know that tan squared theta plus 1 is sec squared theta, then the square root of sec squared theta is just sec theta. So we have tan squared theta, sec squared theta d theta, and then in the denominator we have a sec theta. And then we can see that this sec squared and that one, they can cancel. You'll be left with a sec theta in the numerator. So we're integrating tan squared theta times sec theta d theta. And this is an integral that we have done several times. So we use by parts here. We let u equals to tan theta, du will be sec squared theta d theta, and dv is sec theta tan theta d theta, and v is sec theta. Okay, so our integral of, let's write this, this is tan squared theta. Sec theta d theta. This is u times v, so sec theta tan theta minus the integral of v times du minus the integral of sec to the power of 3 of theta d theta. And we said this sec to the power of 3 of theta, we must write it as sec squared times sec, and then sec squared is tan squared plus 1. So we have sec theta tan theta minus the integral of tan squared theta plus 1 times sec theta d theta, which is sec theta tan theta minus the integral of sec theta d theta minus the integral of sec theta tan squared theta d theta. So you can see sec theta tan squared theta is exactly what we have on the other side. So we take this one to the other side and we get 2 the integral of tan squared theta sec theta. This is sec theta tan theta minus ln of sec theta plus tan theta. Then divide by 2, so the integral of sec theta tan squared theta, there's a d theta here, d theta, this is a half sec theta tan theta minus a half ln of sec theta plus tan theta. Okay, and then now we rewrite everything in terms of x. So remember the substitution that we made. We said that x is equal to tan theta. So we need our triangle. We have theta here. This is opposite over the adjacent, and that is x squared plus 1. Okay, so this means that sec theta is equal to the hypotenuse over the adjacent, which is just square root of x squared plus 1. Then these two terms, tan theta and sec theta, we will substitute them over here. So our answer, the integral of x squared over the square root of x squared plus 1 dx. This is a half sec theta times tan theta. So we have x times the square root of x squared plus 1, and then minus half ln of sec theta plus tan theta, which is x plus the square root of x squared plus 1, and then we add our constant of integration. We have dx over x squared square root x squared minus 9. So here again, we do it in the same way, but this time we have x squared minus a squared. And the substitution we should make is x is a sec theta and a is equal to 3. So x will be equal to 3 sec theta, and this means that the x is 3 sec theta tan theta d theta. And substituting, we have 3 sec theta tan theta d theta over x squared. This is 9 sec squared theta, and then under our square root we have 9 will be common, so we have sec squared theta minus 1. Okay, so square root of 9 is 3. We'll cancel with that one over there. And here sec squared minus 1 is 10 squared, and the square root of 10 squared is just 10. So you can see the 3 will cancel, the 10 will cancel, and then this sec will cancel with one of those. So this is the integral 3 sec theta tan theta d theta over 9 sec squared theta times 3 tan theta. Okay, so we say the tans will cancel, the 3's will cancel, and then sec theta, they will cancel, and I will be left with sec theta in the denominator. So what I'm actually integrating is just 1 over 9, the integral of 1 over sec theta d theta, which is just cos theta. Okay, so I have 1 over 9, the integral of cos theta d theta. This is 1 over 9. The integral of cos theta is sine theta plus the constant. Then we just need to rewrite this in terms of x. So here we said x is 3 sec theta. So sec theta is equal to x over 3. We draw our triangle. This is theta here. Sec, we said, is the hypotenuse over the adjacent, and that means this side will be x squared minus 9. So sine theta is equal to the opposite over the hypotenuse. So our integral then becomes the integral dx over x squared, the square root of x squared minus 9. This is equal to 1 over 9 multiplied by the square root of x squared minus 9 over x plus our constant of integration. You can see that even though we are using the trigonometric substitutions here, the work that we are doing is much less than what we were doing over there. Integral of dx over x squared, the square root of 4 minus x squared. Okay, so here we have a squared minus x squared. So the substitution we make is a sine theta. So we let x equal to a, which is 2, so it's 2 sine theta, and then dx is 2 cos theta d theta. Okay, then we will substitute. This is the integral dx. This is 2 cos theta, x squared. This is 4 sine squared theta. And then under our square root, we have 4, 1 minus x squared, 1 minus sine squared theta. And there's a d theta in the numerator there. Okay, so square root of 4 is 2. We'll see cancels with that one. And then here, 1 minus sine squared is cos squared, and the square root of that is cos, so it will cancel with that. So we will only have 1 over 4 sine squared theta that is left in the denominator. Okay, so this we said is 2 cos theta d theta over 4 sine squared theta times 2 cos theta. So these two cancel with that one, and then we have 1 over 4, the integral of 1 over sine squared theta d theta, and we know that 1 over sine squared theta is cosec squared theta. So this is 1 over 4 integral of cosec squared theta d theta, and the integral of cosec is minus cot. So this is 1 over 4 cot theta, and then we add our constant of integration. And the only thing is to rewrite in terms of x. So we say that x is equal to 2 sine theta. So that means sine theta is equal to x over 2. We draw our triangle. Then sine is the opposite over the hypotenuse, and this is 4 minus x squared. Okay. So we're looking for cot. Cot is the hypotenuse over the adjacent, is the adjacent over the opposite. So cot theta is the adjacent over the opposite, and then we just substitute there. So our answer, what were we integrating? We were integrating dx over x squared square root of 4 minus x squared. This is equal to negative 1 over 4 times the square root of 4 minus x squared over x, and then we add our constant of integration. And that is it. Then the questions in exercise 4.6.5, there's only 10 of them. And you can see that those questions pretty simple to do, because when you substitute, a lot of terms cancel, and the work you will have to do is not as long or as much as when we were just dealing with the trigonometric substitutions. So let's look at some of the questions from the exercise. We have exercise 4.6.5. When we have dx over x 4 plus x squared. So here we have a squared plus x squared. So the substitution we make is in terms of tan. So we let x equal to a, which is 2 tan theta, and this means that dx is equal to 2 sec squared theta d theta. Now we substitute. This is the integral. Dx is 2 sec squared theta d theta, and then x is 2 tan theta, and then 4 will be common, and what do I have? 1 plus tan squared theta. Okay, so here we have 4. The square root of 4 will give us 2, and 1 plus tan squared is sec squared, and then the square root of that will just be sec theta. So you can see this sec theta will cancel with one of those. So what I have is the 2's, I can already cancel them. So I have a sec squared theta then I have tan theta times 2 sec theta d theta. So we said this sec theta will cancel with that, and I'll be left with the sec theta in the numerator. So I'm just integrating half the integral of sec theta over tan theta d theta. Okay, sec theta. So this one we just need to rewrite it. Sec theta we know is 1 over cos. Let me just see, this is 1 over cos, and we're dividing. And then tan is sine over cos. So this is 1 over cos times cos over sine. So this will be 1 over sine. Okay. So this is a half 1 over sine theta d theta, which is a half the integral of cosec of theta d theta, and the integral of cosec theta is one that we know, like the integral of sec theta. This is half ln, it should be negative on the outside. And then we have cosec theta plus cot theta plus our constant. So you can see the integral is similar to the one for sec theta, except here we have a negative. Okay, so that's that one, but we still have to rewrite in terms of x. So keep in mind the substitution that we made. So we say that x is equal to 2 sine theta. X is equal to, 2 tan theta. So this means that tan theta is equal to x over 2. Then we draw our triangle like that. We have theta there. Tan is the opposite over the adjacent. So this means this is x squared plus 4, or 4 plus x squared. Now, what do we want? We want cosec and cot. So cosec of theta, cosec is the inverse of sine. So its hypotenuse not the inverse, the reciprocal of sine. It's hypotenuse over the opposite, and cot is the inverse of cot of tan, so it is the adjacent over the opposite. Okay, so now we can just substitute. Okay, so what we were integrating in the beginning was dx over x 4 plus x squared. This is equal to negative a half. And then ln of cosec theta, the square root of x squared plus 4 over x. And then plus cot theta, which is 2 over x. And then your constant of integration over here. Now notice here, you cannot just get rid of the denominator and then say, I'm going to add it to this, because your denominator has an x, which is not a constant. So if this was just a number, let's say 3, I could rewrite it without the denominator here and say I've added it to this constant, but x here is not a constant, so it cannot just be added to a constant and then you get a constant. So just be careful with that. And let's see, number 2. Yeah, let's do number 2. Number 2, we have dx over x squared, square root of 1 minus x squared. So here we have a squared minus x squared, so we should think our integral is going to involve, our substitution is going to involve sine. So we have x is equal to a, which is 1, and then we have sine theta, and this means that dx is equal to cos theta d theta. Then we substitute, we have cos theta, our x squared is sine squared theta, square root of 1 minus d theta. Okay, so we have cos theta over sine squared theta times cos theta d theta. Those two will cancel. And then I have the integral of 1 over sine squared theta d theta. So this is the integral of 1 over sine squared theta d theta, which is the integral of cosec squared theta. Okay, the integral of cosec squared theta, we say it is minus cot theta plus c. And then for our substitution, we said x is sine theta. So we draw our triangle. So sine is the opposite over the hypotenuse. So this is 1 minus x squared. Okay, so cot theta will be the adjacent over the opposite. And then we write down what we were integrating, the integral of dx over x squared times the square root of 1 minus x squared. This is equal to negative square root of 1 minus x squared over x plus our constant of integration. the 3 x squared, then 4 minus x squared dx. So here make a similar substitution because this is a squared minus x squared. Our substitution will be a sine theta. So this is 2 sine theta, and dx is equal to 2 cos theta d theta. Okay, then substituting x squared, this is 4 sine squared theta, the square root of 4, 1 minus sine squared theta, and then times 2 cos theta d theta. Okay, right. So here I have the integral of 4 sine squared theta times 2 cos theta times 2 cos theta d theta. This is 16 sine squared theta cos squared theta d theta. Okay, so this is what we have. The 16 can go out, and remember we've solved questions like this, so I expect you to remember how to do it. We have sine squared and cos squared. We can rewrite them using the double angle identities. So this is 16, and then we have a half 1 minus cos 2 theta. That's for sine squared theta. And then the other one is a half 1 plus cos 2 theta. And then we have d theta. So we have 16 times half is 8 times half is 4. So the 4 can even go outside. And then we have 1 minus cos 2 theta, 1 plus cos 2 theta d theta. This is just a difference of squares, and we can write this as 4 integral of 1 minus cos to the cos squared of 2 theta. Okay, and d theta, yeah, and 1 minus cos squared 2 theta is the same as sine squared 2 theta, and then the sine squared 2 theta we would rewrite it using the double angle identities. This is 4. Okay, so this is 4, and we have a half here, and this is 1 minus cos 4 theta d theta. Okay, then this half can multiply with that one, so we have a 2 outside. 1 minus cos 4 theta d theta. This is 2 theta minus 2. The integral of cos is sine, so we have sine 4 theta, and then we divide by 4 and then add our constant of integration. So just writing it nicely, this is sine 4 theta over 2 plus c, and then our substitution. What was the substitution? We said x is equal to 2 sine theta, and this means that sine theta is equal to x over 2, but then we need sine 4 theta. Okay, sine 4 theta, we know that is 2 sine 2 theta cos 2 theta, and then, oh, okay, here what I did is just trying to think of the shortest way to do it. So we have sine 4 theta. We know that this is sine of it's 2 sine 2 theta cos 2 theta. This is 2 sine theta cos theta, and then multiply this by cos squared theta minus sine squared of theta. Yeah, this is very long. Let's see. We have this is theta. So this is x over 2. This is the square root of 4 minus x squared. Okay, so if we substitute into sine 4 theta, we have 4. See, sine 4 theta. This is 4. Sine theta is x over 2. Cos theta is the square root of 4 minus x squared over 2. And then cos squared minus sine squared. We have 4 minus x squared over 2 minus x squared over 2. Okay, the 4's can cancel. Okay, or alternatively, what we can do, because this, I don't want to write a lot of things. If we know what theta is, we can also just substitute it over there. So we know that sine theta is x over 2. Then from here, this means that theta is equal to sine inverse of x over 2. So I could just have 2 sine inverse of x over 2, and then sine of 4 times sine inverse of x over 2 divided by 2, and then I add my constant of integration. So you could break it down like this, or you could just write it like that. Either one I think is fine. So let me write the shorter one. So we said 2 theta. Write the whole question. What were we integrating? Of x squared and 4 minus x squared dx. We say this is 2 theta, so 2 times theta and then minus a half times sine 4 theta minus a half sine of 4 theta. Then plus our constant of integration. Then you can just leave it like that. There isn't much we can do to simplify it. Let's look at number 7. Let's see, number 7, 8. Number 7. Integral of dx over x, the square root of 16 plus 9x squared. Okay, so that is what we have. And here we have to first rewrite it in the form a squared plus x squared. So doing that, we have the integral of dx over x and the square root of 16. We take the 9 out, 16 over 9 plus x squared. Okay, so here we have a plus, so our substitution must be 10. So we let x equal to a, which is 4 over 3, 10 theta, and that means that dx is equal to 4 over 3 sec squared theta d theta. Here, say dx okay, then we substitute dx. This is 4 over 3 sec squared theta d theta, then 3x square root 16 over 9 will be common, so we take that out, and we have 1 plus 10 squared. This x here, I should also substitute it. And then times x, which is 4 over 3, 10 theta. Okay, so we can see 4 over 3 and 4 over 3 cancel. Then this will be 4 over 3 and this will be sec theta. So sec theta will cancel with that, one of those sec thetas in the numerator. So what I have is the integral of sec squared theta. Then I have my 3 and 4 over 3. One plus 10 squared, we say it is sec squared, the square root is sec theta. And then the 10 theta, and then d theta. So this one, that one will cancel. We'll have a sec theta in the numerator. This 3 and that 3 will cancel. So I'm just integrating sec theta over
Mister,
10 theta. Yeah.
what happened to the x at the 3?
You mean this x?
At the beginning, close to the integral sign.
This one here?
Yeah. Why is
It's
there
this
only a
one
3
here.
now?
It's here.
Oh, okay.
Okay, so sec theta over tan theta. Oh, there's a 4 here. D theta. Okay, then sec theta over tan theta, we just need to rewrite that. So sec, we say is 1 over cos. Yeah, I think we did this one before. Sine over cos. This is 1 over cos times cos over sine, 1 over sine, which is cosec. Yeah. So this is 1 over 4, the integral of cosec theta d theta. Okay, then integrating this one, we said the answer is just negative 1 over 4 ln of cosec theta cot plus cot theta. And our constant. Then our substitution, we said x is equal to 4 over 3 tan theta. So we have 3x over 4 is equal to tan theta. And there's our triangle. We have theta there. Tan is opposite over the adjacent. So this is square root of 9x squared plus 4 plus 16. Yeah. Okay, so this means that cosec theta, cosec is the inverse of sine, so it's hypotenuse, the reciprocal, not the inverse. Hypotenuse over the opposite, and cot is the adjacent over the opposite. Okay, then we just substitute everything here. So the integral of dx over x square root of 16 plus 9x to the power of 2. This is negative 1 over 4. Then ln of cosec theta square root of 9x squared plus 16 over 3x. Then 4 over 3x, and then add your constant of integration. Can do one more, number 10. Now, how many have we done now? Okay, do just one more, number 10. We have to integrate dx over x squared, square root of x squared minus 7. Here we just let x equal to the square root of 7 sec theta, and then dx is equal to the square root of 7 sec theta tan theta d theta. Then we substitute. This is the integral of dx, square root of 7 sec theta tan theta d theta. Our x squared, this is 7 sec squared theta. The square root 7 will be common, and then we have sec squared theta minus 1, like that. Okay, so already we can see that sec and this one will cancel. You have a sec theta there. Then here, this square root of 7 and that one will cancel. Then over here, this sec squared theta minus 1 is tan squared theta. The square root of that is just tan, which will cancel with that one. So we have the square root of 7 tan theta over 7 sec theta times the square root of 7 tan theta. Okay, so that there's a d theta there. That cancels. And this is 1 over 7, the integral of 1 over sec theta d theta, which is 1 over 7, the integral of cos theta d theta. Okay, the integral of cos is sine, so this is 1 over 7 sine theta plus our constant. Then our substitution, x is, let me just move everything up. Okay, so we said x is equal to square root of 7 sec theta. So this means that sec theta is equal to x over the square root of 7. We can draw our triangle. Okay, sec is the adjacent over the hypotenuse, and this side will be the square root of 7 minus x squared. Okay. It's x over that. I think I swapped these. It is the hypotenuse over the adjacent. Yeah. Yes. And then we get x squared minus 7. Okay, so we need sine. So sine theta, this is the opposite over the hypotenuse, x squared minus 7 over x. Okay, then our final answer, the integral of dx over x squared minus 7 this is 1/7 times the square root of x squared minus 7 over x, and then you add your constant of integration. Right, so the other questions in the exercise, you would do them the same way. Then that concludes the techniques that we will be looking at for integration. So any integral that you get will involve one of those techniques, and you should be able to do it. So remember, the test is next week Friday, so keep preparing for that, and we'll continue on Monday.